It is well known that hydrogen is an energy carrier and storage medium of choice for many renewable energy systems. For instance, in the last few years, we have seen more and more companies, research institutions, and even governments working towards adopting hydrogen as the primary energy source for transportation and stationary applications. But how often do we think about the safety aspects when discussing this future hydrogen-based energy system? Around 20% of all stars in the universe consist of hydrogen. It is present in water, in food, and even in our own bodies. But it is the only element in that group that exists as a gas at room temperature. Depending on the application and storage method used, hydrogen can pose several risks. The simplest way is by mixing hydrogen with oxygen in any proportion from 4% to 75% concentration. If ignited, this mixture will burn. One of them is to dilute hydrogen with an inert gas like nitrogen or argon to reduce the flammability. However, this increases the cost and complexity of the system and may require additional safety measures. If the pressure inside the storage vessel exceeds the vessel's capacity, it can rupture, causing a sudden release of large amounts of hydrogen. With proper handling, storage, and utilization, the risks associated with hydrogen can be effectively managed. Advancements in safety technologies, stringent regulations, and public education play a vital role in ensuring the safe use of hydrogen. By prioritizing safety and implementing appropriate measures, we can harness the potential of hydrogen while minimizing its associated risks. Hydrogen burns faster than most conventional fuels, making it more difficult to extinguish. As we continue to explore and develop hydrogen-based technologies, it is crucial to prioritize safety at every stage of the hydrogen supply chain. From production to end use, we must implement rigorous safety measures, conduct thorough risk assessments, and continuously improve our safety protocols. By doing so, we can harness the potential benefits of hydrogen while mitigating its associated risks. Remember that safety should always be a top priority in our pursuit of a cleaner and more sustainable energy future. Additionally, hydrogen fires can cause explosions, which can spread fire and cause significant damage. To mitigate these risks, specialized extinguishing systems and equipment should be used when dealing with hydrogen fires. Training and education play a crucial role in managing the risks associated with hydrogen fires. Firefighters and emergency personnel need to be equipped with the knowledge and skills to handle hydrogen-related incidents effectively. This can lead to a fireball or explosion depending on the amount of stored hydrogen. To mitigate this risk, regular inspection and maintenance of storage systems are crucial. Additionally, implementing overpressure protection devices such as ruptured discs can help prevent vessel failure. Using advanced sensors to detect leaks early is another effective method. Regular maintenance and inspections can also help in identifying potential issues that could lead to leaks. Driving a car, cooking food, even breathing. All these activities carry a certain amount of risk. However, we cannot eliminate all the risks. When hydrogen is used as a fuel, it can release energy in the form of heat and light. This property makes it valuable for various applications. However, it also poses unique challenges in terms of safety. The combustion of hydrogen can be highly exothermic, meaning it releases a significant amount of energy. When hydrogen burns, it reacts with oxygen in the air to produce water vapor and energy. This reaction can be highly efficient, but it also generates heat. The amount of heat released depends on the amount of hydrogen being burned and the efficiency of the combustion process. Proper ventilation and monitoring are crucial to prevent the buildup of harmful combustion products. Additionally, measures should be taken to prevent the ignition of hydrogen-air mixtures, as this can lead to explosions. Hydrogen has a wide flammable range, making it susceptible to ignition over a broad range of concentrations. Therefore, it is essential to implement robust safety protocols, including leak detection systems and emergency response plans. Instead, we focus on reducing them to acceptable levels. Safety should always be a top priority. In the case of hydrogen, there is a need to raise public awareness and understanding of its properties and potential hazards. Educational programs and community engagement initiatives can help people become more familiar with hydrogen and how to handle it safely. Furthermore, implementing robust procedures and protocols for handling hydrogen and providing proper training to personnel are crucial. Using advanced materials for storage and transportation, such as Type 3 and for hydrogen storage vessels, can minimize the risk of leaks. These vessels are made of composite materials that are much lighter and safer than traditional metal cylinders. They are also more efficient since they allow for higher storage capacity. Hydrogen air mixtures are also sensitive to changes in pressure and temperature, so a rise in temperature or a decrease in pressure can trigger ignition. As mentioned earlier, hydrogen has a very high auto-ignition temperature. But if it is mixed with impurities such as carbon monoxide, sulfur compounds, and nitrogen oxides during production, storage, or transportation, it can lower the ignition temperature and increase the risk of fire. Another possibility is the presence of hot surfaces. Hydrogen can undergo auto-ignition when brought into contact with a surface that is hotter than 571 degrees Celsius. At ambient conditions, the main risk associated with hydrogen is its flammability. Hydrogen is considered to be more dangerous than natural gas because it has a wider flammable range. This is mainly due to its ability to displace oxygen. In enclosed spaces, hydrogen can accumulate and crowd out oxygen, creating an oxygen-deficient environment. Inhaling pure hydrogen can lead to a lack of oxygen in the body, which can cause unconsciousness and eventually death. Hydrogen can also cause asphyxiation by displacing oxygen in confined spaces. Leaks in the distribution system or equipment can lead to the accumulation of hydrogen in underground spaces or within buildings. In the event of a leak, it is crucial to ventilate the area to prevent the buildup of hydrogen and to ensure adequate oxygen levels. Continuous monitoring of oxygen levels can help detect potential issues early. Implementing proper ventilation systems and maintaining a safe working environment are essential to prevent accidents. Moreover, it can form explosive mixtures with air inside pipes or equipment. Leakages can occur at any point along the supply chain, which includes production, compression, storage, transportation, and end use. If such leaks are not detected and properly addressed, they can cause serious problems. A simple spark or flame can cause the mixture to explode and can lead to catastrophic consequences. While hydrogen does not burn, it can support combustion of other materials. Fires involving hydrogen can be difficult to extinguish since hydrogen does not burn and may not produce enough heat to sustain the combustion reaction. Additionally, it is important to note that explosions due to hydrogen are usually more intense than those caused by other fuels. We can find diatomic hydrogen molecules in both liquid and gaseous state on Earth. The reason why it is usually found in molecular form rather than in its atomic form is because of its high ionization energy. In order to remove an electron from a hydrogen atom, we need a lot of energy. Consequently, hydrogen tends to share electrons rather than gaining or losing them. As a result, it tends to form molecules by sharing electrons with other atoms. Hydrogen molecules are extremely strong and they tend to stay together. However, they can be split up into individual atoms through chemical reactions. This process is called electrolysis, and it is used for hydrogen production from water using electricity. Hydrogen produced this way is called green hydrogen. In fact, about 75% of the universe is made of hydrogen. However, we generally do not come into contact with molecular hydrogen H2 in our everyday life. Therefore, in order to fully understand the safety issues related to hydrogen, we must first learn how it behaves under different circumstances. Is it safe to use hydrogen? What are the safety concerns surrounding hydrogen production, transport, and end use? Can we leverage existing safety technologies to ensure the safe use of hydrogen? Today, We will address all these questions and try to give you some clarity on the subject. So stay tuned, but before we get started, now let's talk about safety. Before we start discussing safety in detail, it is important to answer the question, what makes hydrogen unique when it comes to safety? Well, first of all, hydrogen is one of the most flammable substances known to mankind. Its autoignition temperature is around 571 degrees Celsius. This means that if a hydrogen fire gets out of control, it can easily ignite itself. That is a major concern for safety, and secondly, hydrogen is very light. The lightest form of hydrogen is called orthodeuterium, which has only 39 atomic mass units. This means that if there is a leak in the storage or transportation system, it can spread quickly over large areas unless there is an active and reliable detection system in place. Lastly, while pure hydrogen gas is not toxic, it displaces oxygen and forms explosive mixtures with air. If inhaled, it can lead to asphyxiation. These factors pose unique challenges when it comes to the safe handling and use of hydrogen. However, we should also keep in mind that hydrogen is everywhere. It is literally part of our daily lives. If we look at the periodic table, hydrogen is placed in group 1, also known as the alkali metals. In order to utilize hydrogen as an energy storage medium, we need to compress it or cool it down to liquefied state in order to store it at relatively high pressures or low temperatures. Hydrogen fires can happen in several ways. There are some methods to mitigate the flammability risks. Although hydrogen is non-toxic, it can still be dangerous to humans. Another concern is the potential explosion of hydrogen storage systems. In conclusion, while hydrogen presents unique challenges when it comes to safety, it is important to recognize that hydrogen is not inherently more dangerous than other energy sources. In today's world, everything we do involves some level of risk. We have been discussing the flammability and explosivity risks of hydrogen. But what about the safety of hydrogen as a fuel? Hydrogen fires can pose unique challenges due to their speed and intensity. Hydrogen is considered to be a promising energy carrier for a sustainable future. We hope you found this video informative, and we encourage you to stay tuned for more videos on hydrogen technology. Thank you for watching.
So now, a bit about me. My name is Mike L., and I am an experienced electrical engineer who has worn many hats, holding key roles in projects, engineering, planning, operations, asset management, maintenance, and field resources development. I design and pioneer engineering solutions to propel the utility and energy industry forward. My passion within the industry has also driven me to develop educational materials for the new generation of utility and energy professionals. The knowledge I teach is not only based on my own experience within the power utility industry, but also on knowledge gaps identified by other professionals in the field. Learning from me will provide you with the comprehensive, fundamental knowledge you need to kickstart your professional career in the utility industry. If you are interested in what I have to teach, check out my courses at Udemy and connect with me on LinkedIn, X, and Facebook. Don't forget to comment, like, and subscribe this video. Bye for now.